Welcome to the educational module Introduction to the Internet of Things of SendingVet program. The current section is to introduce you to the Security and Privacy module. The IoT may be the most unsecure network encounter so far. Things are now connected to each other, forming their own network in a user's private life. IoT is connected to the highly unsecure network, the Internet, making it more vulnerable and appealing for malicious intervention. The IoT is now part of our everyday routine. IoT applications include smart cities, transport, monitoring critical infrastructures, smart thermostats, and many more. Most, if not all IoT applications, rely on accurate and on-time information. Loss of information can result to inaccurate environmental measurements and erroneous decision-making. In certain IoT applications, the user cannot directly control the security level of the network. A computer owner can control the level of security on his or her computer by adapting security measures, not downloading certain applications, using security software, etc. Smart city applications can draw attention to perpetrators as the IoT applications become massive databases for the city. A citizen in a smart city cannot control the security measures employed in the IoT and thus cannot control his or her privacy level. The same applies in every application in which the user may use and has access to the user's privacy. In general, attacks aim in diminishing or eliminating a network's capacity to perform its expected function. This can be done by exploiting vulnerabilities in the system. Security is an essential part for the IoT. They are mostly related to someone's personal life or an industry. One of the challenges of IoT is that multiple architectural styles exist, and thus security needs to be addressed in all IoT architectural components. There are many types of attacks that are executed deliberately to either disrupt the network, gain information, and/or change the data. Specifically, there are three categories of attacks: the intrusion, the blocking, and malware. The intrusion attacks includes attacks meant to breach security and gain unauthorized access to a system. This is generally what hackers do. Blocking includes attacks designed to prevent legitimate access to a system. Blocking attacks are often called denial of service attacks, or simply DOS. In these types of attacks, the purpose is not to get into your system but simply to block legitimate users from gaining access. A DOS attack aims to make a system unavailable and to disrupt an application by causing a massive number of requests sent to the system. DOS attacks seek to overload the target device by launching connection requests. A DOS attack that is launched from several different devices, IoT botnets, is called a distributed denial of service, or DDoS. Mirai is an example of DDoS attack in the IoT. Malware is a generic term for software that has a malicious purpose and is probably the most common threat to any system. One reason is that malware is often designed to spread on its own, without the creator of the malware having to be directly involved. It includes virus attacks, which is the most common attack, ransomware, Trojan horse, and spyware. Mirai botnet malware is one of the first examples of infecting unsecure IoT network devices running Linux machines such as IP cameras and home routers. Mirai was launched in September 2016 and it is an example of how easy it is to launch a distributed denial of service attack, DDoS, in the IoT. Mirai scans the Internet for the IP address of Internet of Things, IoT, devices. Within the code, the WR hard-coded a list of IP address ranges that it will not infect, including private networks and addresses allocated to the United States Postal Service and Department of Defense. Once it encounters things, it uses a table of more than 60 common factory default usernames and passwords and tries to log into them to infect them. Overall, IP addresses of Mirai infected devices were spotted in 164 countries. There were at least 500,000 known Mirai botnets. The current table shows a partial list of the usernames and passwords that were used by Mirai botnet to access the device. As you can see, the username was either left unchanged, such as the username root, or used variations of specific words and/or repeated numbers. Most common words are the administrator, with capital A, and administrator with lowercase a. You can see the same word was also repeated in smaller size version of the word, such as admin, or admin1. Other common usernames include user, guest, tech, and even the word mother is frequently used as a username. Numbers are also a common username, such as pressing number 6 times, or number 8. Common password words include again root, admin, default, user. There are cases in which no password was set, it was left blank. Numbers were also used as passwords, but were easy to guess since they follow a sequence 1 2 3 4 5 6 and 5 4 3 2 1. The goals of security in a nutshell is to provide a security connection, a secure remote access, to ensure privacy, to provide no repudiation, and to establish the CIAD triad. The CIAD trial are the initials of confidentiality, integrity, and availability. Security is a mandatory field and needs to be applied especially on the IoT networks. More security and privacy details will be presented on the security and privacy section. Thank you for listening.